Hi, 8th grade. Welcome to lesson 3-4, construct functions to model linear relationships. By the end of the lesson, I want you to be able to say, I can write an equation in the form y equals mx plus b to describe a linear function. Let's explore it. Eric wants to buy a new mountain bike that costs $250. He already has saved $120 and plans to save $20 each week for the money he earns mowing lawns. He thinks he'll have saved enough money after 7 weeks. Complete the table and graph the data. So at 0 weeks, it has $120 because that's what he's already saved. And it says he saves $20 each week. So fill out the table, and then fill out the graph, and we will continue when you're ready. Okay, so hopefully you have 140, then 160, then 180 on the table. So I can graph that. At time 0, I'm at 120. I got to figure out what my scale is here. Between 120 and 180 is 60. So halfway between that is going to be 150. Halfway between 180 and 240 is going to be 210. So at time 0, we're at 120. At time 1, we're at 140. Time 2, we're at 160. Time 3, I'm just going to continue. Time 3, I'm at 180. Time 4 is 20 more than that, so I'm at 200. Time 5 is 20 more than that, that's 220. Time 6, 20 more than that, 240. Time 7 would be at 260. So he wants to have enough money after 7 weeks. How can you tell the relationship is a linear function from the table? How can you tell from the graph? Well, first of all, let's answer the question. 7 weeks, he's going to have $260. The bike is $250, so yes, he will have enough money. So how can we tell it's linear from the table? Well, from the table we can tell because each time it increases by the same amount. So from 120 to 140, it's plus 20, plus 20, plus 20, and plus 1, plus 1, plus 1. So the y and x increase at the same amount. So from the graph, you can tell because it increases by the same amount. Remember that vocab word from last time, constant rate of change. So our constant rate of change here was 20 because it's 20 over 1. Remember, that's also our slope. You can tell it's linear from the graph because it makes a straight line. How can different representations help you determine properties of functions? So the different representations can tell you the slope, or we're using now constant rate of change. And they can also tell you the y-intercept, which we are calling the initial value, because that's where you're starting from. All right, example number 1. Write a function from a graph. A plan for a skateboard ramp shows the plywood for the triangular sides of a ramp should be cut such that for every 9 inches of height, the triangle should have a base that's 33 inches long. What is the height of the skateboard ramp shown? So we know every 9 inches of height, we go up 9. We have to go over 33. Well, guess what? That is, here's our ramp. That is a slope. Remember, slope is rise over run. So use a graph to determine the situation, or to represent the situation and determine the slope. So we see that it's 9 over 33, or reduced to 3 over 11. So then use the slope to write an equation that represents the function shown in the graph. Y equals mx plus b. We just found that our slope is 3 over 11. So instead of m, we're going to put 3 over 11. And we don't have a b, so I'm going to erase this. We don't have a b because if we don't go over 0, we don't go up any. So it's starting at 0. Now it wants to know, when is the base length going to be 110? So the base length is how much it goes over, not how much it goes up. So over left and right is my x value, up and down is my y. So instead of x, we're going to substitute in 110. Then multiply, we can put 110 over 1. 3 times 110 gives me 330. Divided by 11 equals 30. So the height of the ramp should be 30 inches. Let's try it. How will the height of the ramp change if the plan shows that for every 3 inches of height, the triangle should have a base that's 15 inches long? So we're going to start at 0, 0. If we go up 3, we have to go over 15. Up 3, over 15. Follow the pattern. And I can connect my dots. Here's my ramp. So my rise is 3. My run is 15. I can reduce that because 3 and 15 are both divisible by 3 to 1 over 5. So the slope of the function shown in the graph is 1 over 5. So the equation is y equals 1 over 5x. If the base length is 110 inches, okay, so I'm going to rewrite my equation. Y equals 1 over 5x. The base length is on the x-axis. So if my base length is 110, I'm going to substitute in 110 for x. I can put 110 over 1, multiply straight across. 110 divided by 5 is going to give us 22. So the height of the ramp will be 22 inches. Explain why the initial value and the y-intercept are equivalent. The y-intercept is when x equals 0. And what that means is, look, y-intercept is on the y-axis. You follow it down here, x is 0. So that is the initial value because x usually stands for time. So when x is equal to 0, our time is 0, meaning that's where we start. Example number 2. Write a function from 2 values. The cost to manufacture 5 toys is $17.50. And the cost to manufacture 10 toys is $30. Construct a linear function in the form y equals mx plus b that represents the relationship between the number of toys produced and the cost of producing them. So the number of toys produced is x, and the cost is y. So technically I can write this as 5, $17.50 and 10, $30. So now I have 2 ordered pairs. Well, to find the constant rate of change, or slope, we can use the slope formula. Remember, y2 minus y1 over x2 minus x1. I label my points. This is x1, y1, x2, y2. They fill that out for us. 30 minus 17.5 over 10 minus 5. Subtract and divide. So the constant rate of change is 2.5. That is my slope. The next thing we're going to do, so I could write my equation, y equals 2.5x plus b. But what are we still missing in this equation that we have to fill out? We still have to find the b, but we don't know the initial value. They didn't tell us that. What you can do is pick any of the points. So they picked the 1030, which I would have picked that as well. We don't have to deal with decimals then. And they plugged that in. So instead of y, they plugged in the 30. kept everything else the same, 2.5. Instead of x, they plugged in 10 and plus b. Now we're going to solve in order to solve for b. So the first thing I'm going to do is keep the 30. 2.5 times 10 is 25. Sorry, this should be 30 equals 25 plus b. Now in order to get b alone, I'm going to use my inverse operations. 25 is being added to b, so I'm going to subtract it from both sides. This cancels out. 25 minus, or 30 minus 25 is 5, so b equals 5. So putting that all together, I can write the equation y equals 2.5x plus 5. Let's try it. Jin is tracking how much food he feeds his dogs each week. After 2 weeks, he used 8.5 cups of dog food. After 5 weeks, he used 21 1/4 cups. Construct a function in the form y equals mx plus b to represent the amount of dog food used y after x weeks. So I've got 2 weeks with 8.5 cups. So I'm going to write that as 2, 8.5. And then 5 weeks with 21 1/4. So I'm going to write that as 5, 21.25. First thing I need to do is find the constant rate of change. So that's my slope. Remember slope formula? We can do this x1, y1, x2, y2. So I do 21.25 minus 8.5 divided by 5 minus 2. Get out my handy dandy calculator. 21.25 minus 8.5 gives me 12.75. 5 minus 2 is 3. So divide 12.75 by 3 and we get 4.25. All right, I'm going to continue this problem on the side here because I'm running out of room. I apologize if you don't have room either. Try and find space. So we just found out that our slope, our constant rate of change, is 4.25. So I plug that into my equation of y equals mx plus b, but I still need to find b. So just like before, we pick one of the points. So I'm going to pick the point 2, 8.5. Plug in my x and my y. So instead of y, I'm going to put 8.5 equals 4.25. Instead of x, I'm going to put a 2 plus b. Now we have to solve for b. So I'm going to first multiply. So I leave the 8.5. 4.25 times 2 is 8.5. And now to get b by itself, I use inverse operations. So I'm going to subtract 8.5 on both sides. And this cancels to 0. This cancels and I'm left with b equals 0. Well, that makes sense. If it's been 0 weeks, we need 0 cups of dog food. So our final equation is y equals 4.25x. You don't have to put the plus 0 because adding 0 is like adding nothing. All right, example 3, interpret a function from the graph. The graph shows the relationship of the height of a burning candle over time. What function represents the relationship? So all you got to do is look for the y-intercept. So the initial height is 10. And you need to follow the slope, down 1 over 1, down 1 over 1. So that's -1. Let's try it. This graph shows the relationship between the number of pages printed by a printer and the warm-up time of each printing. What function represents the relationship? Well, we start at 1, so I know my b equals 1. And I'm going to look at my slope. I go up 1 over 2, but careful, it's boxes. Check to see how much each box is worth. It's up 1, but it's over 10. So my rise is 1, my run is 10, meaning my slope, my constant rate of change, is 1 over 10, and my equation is y equals 1/10 x plus 1. All right, 8th grade, let's say it. I can write an equation in the form y equals mx plus b to describe a linear function. Have a great day.